Alright, ladies and gentlemen, today we're delving into our first bout with factoring. So we're looking to factor polynomials of the form x squared plus or minus bx plus c. So these are quadratic trinomials. Basically, our first several lessons are all going to be on different ways that you can factor quadratic trinomials. As a quick side note, something that I forgot to add to the note sheet, which I guess makes sense, is you should probably know what is factoring. Well, in terms of numbers, if we were to factor the number 6, it would mean to write it in terms of multiplication of prime numbers. So we'd write it as 2 times 3. Or if we were looking at maybe a little bit of a more complicated number, we could look at the number 18, which we could write as 9 times 2, but we could break that down even further into 3 times 3 times 2. That's the process of writing the prime factorization of a number or factoring numbers. The process is basically the same for expressions. What we're trying to do is take an expression and rewrite it into smaller expressions that multiply into that expression, that multiply to be that expression. So, here's what we're going to do. We're going to recap multiplying. I'm going to have 4 multiplication problems for you to do. All 4 of these are going to be binomial times binomial. And I'm going to have you multiply all 4 of these. I'll have you pause and then come back. And then what I'm going to have you do after that is we're going to investigate some patterns and kind of see what we can see here. Okay? So here are the 5 problems that I want you to try. X plus 4 times x plus 5. X plus 2 times x plus 9, x minus 3 times x minus 5, and x minus 4 times x minus 5. So what I want you to do is multiply these sets of binomials together, just like from the last lesson. Pause and then come back. Okay, welcome back. So hopefully for this one, you got x squared, and I'm already doing all the simplifying already, so if you showed more work than I did, that's fantastic. I'm really happy for you. Okay, so hopefully you got x squared plus 9x plus 20 for the first one, x squared plus 11x plus 18 for the second one, x squared minus 8x plus 15 for the third one, and x squared minus 9x plus 20 for the last one. What I want you to do is look at what you started with and look at the answer. I want you to see, is there some kind of pattern? More importantly though, I actually want you to look and see, okay, the idea is this is multiplying. When you go from here to here, that's just multiplying. But when you go back and try to figure out what these are, starting from the right side, going to the left side, that's what we call factoring. So what I want you to do is see, is there something you notice in this expression that could help you work your way back to this expression? Is there a pattern in the numbers that show up here with the pattern that shows up here? Pause, think about that for a second, try to write something down, see if you can see what the pattern is. Okay? After you unpause, I'll give you a hint. Okay, so if you needed a hint, what you're going to find is that there's a relationship between, all of them start with x squared, right? Because our polynomials started with x and x. Both of our binomials did. But there's a relationship between these 2 numbers and these 2 numbers. See if you can figure out what that is. Again, pause and come back if you need to, if you didn't figure it out yet. So the pattern that you see is that the numbers that go in parentheses needed to multiply to the constant term, or that last term, that last I should say the last coefficient, and they need to also add to the middle coefficient. So let me show you what I mean. If I were to start with 20 and 9, if I look over here, and knowing that I get 4 and 5, 4 and 5 multiply to 20 and add to 9. 9 and 2 multiply to 18 and add to 11. 5 and 3 multiply to 15 and they add to -8. They're both subtraction signs. -5 and -4 multiply to positive 20 and add to -9. So what you're going to do is we are going to be always looking for numbers that multiply to the last and add to the middle when you're trying to find those original two numbers that were in parentheses. Here's some proof if we kind of need it. If I were to multiply x plus c times x plus d, here let's even put a plus or minus symbol in the middle and let's work it with both at the same time. If I multiply this out, I get x squared plus or minus dx plus or minus cx, and I definitely get a plus d because if both, or I get a plus d times c. Okay, so I'm going to always get a positive last number because I'm either multiplying two positives or two negatives. But now if I were to, these two are going to be like terms, right? And so in the middle, I'm going to have this combination of d and c. I'm going to add those two things together. And they're going to multiply over here. Okay, so I'm always looking for numbers that multiply to this last term and add to this middle term. So here's how this works. What I do is when I know that I'm trying to factor this, I know it must have started off as two binomials. And those binomials needed to both start with x because when I do the multiplying process, the first thing I'm going to get is just x squared. So they both had to start with x. And then the way I figure out the numbers that go here and here, numbers 1 and number 2, in this case they need to multiply to 26 and add to 15. Two numbers that multiply to 26 and add to 15 are 13 and 2. So I put a 13 in one and a 2 in the other. That's it. Now if I wanted to check my answer, I'd multiply this back out. And sure enough, those two will combine to 15, and it works. So that's my answer. Fantastic, right? Not too hard. So you're looking for numbers that multiply to the last and add to the middle. Here's what I want you to do. I want you to try these three on your own. I know it's your first look into factoring, but that's really all it is. You're just trying to go back and figure out what those original two binomials were. So try these three, pause, and then come back. All right, for this one, we were looking for numbers that multiplied to 25 and added to 10. That's 5 and 5. X plus 5, x plus 5. Here, we're looking for numbers that multiply to 5 and add to -6, because we got a negative in the middle. So it's going to be two negative. It's going to be x minus and x minus this time. It's got to be two negatives because we need the positive at the end, but the negative in the middle. And it's 5 and 1. Those are the only things that multiply to 5, but -5 and -1 also add to 6. And here, we get -7 and -2. Guys, that's really all there is to it. And what you should get in the habit of doing is, if not, even if you don't do it on paper and show the work, you should get used to kind of multiplying it back in your head to make sure it works. So kind of here's how I would do this one. I'd go x times x is x squared. Okay, there I got my x squared. Then I get a -1x and a -5x. Yep, that makes my -6x. And -5 times -1 is +5. Boom, it works. Okay, so factoring is really just the process of going from an expression back to the original polynomials that multiplied together to make that expression. Okay, it's a lot of pattern recognition. Okay, that's it for this one. Hope you learned a little something.